Variation, direct and indirect. Direct variation. In a variation, if variables change proportionately, i.e. either increase or decrease together, then it is called as direct variation. If x is in direct variation with y, it can be symbolically written as x is proportionate to y. Inverse or indirect variation. In inverse or indirect variation, the variables change disproportionately, or when one of the variables increases, the other one decreases. So behaviour of the variables is just the opposite of direct variation. That is why it is called as inverse or indirect variation. If x is in indirect variation with y, it can be symbolically written as x is proportionate to 1 over y. Example 1. Y varies as z, and y equals 2 when z equals 5. Find A, the value of y when z equals 6, B, the value of z when y equals 5. A. Always start with the statement y is proportional to z. The proportional sign can be replaced by y equals kz. We can now substitute in. We know that y is 2 when z is 5. Therefore, 5k equals 2, so k equals 2 over 5. Therefore, y is equal to 2 over 5 z. Therefore, when z is 6, y equals 2/5 times 6, which is 12 over 5, which equals 2 and 2/5. B. We already know that y is equal to 2/5 z. Therefore, when y is 5, we've got 5 equals 2/5. Therefore, z is equal to 25 over 2. Therefore, z is equal to 12 and 1/2. Example 2. The distance d through which a stone falls from rest is proportional to the square of the time taken, t. If the stone falls 45 meters in 3 seconds, how far will it fall in 6 seconds? How long will it take to fall 20 meters? We know from the information that d is proportional to t squared. Therefore, d equals kt squared. Therefore, substituting in the values, d is 45 when t is 3. Therefore, 45 equals k times 3 squared. Therefore, 45 equals 9k. Therefore, k equals 5. Therefore, we can have the equation d equals 5t squared. Therefore, when t is 6, we get d equals 5 times 6 squared. So d equals 5 times 36. Therefore, d equals 180 meters. When d is 20, we get 20 equals 5t squared. Therefore, t squared equals 4. Therefore, t equals 2. Inverse proportion. Example 3. Z is inversely proportional to t squared, and z equals 4 when t equals 1. Find A, z when t equals 2, B, t when z equals 16. Firstly, write z is proportional to 1 over t squared. Replace the proportional sign with equals k, therefore z equals k over t squared. Substitute in the values z equals 4 when t equals 1, therefore 4 equals k over 1 squared is 1, therefore k equals 4, therefore z equals 4 over t squared. A, find z when t equals 2, therefore z equals 4 over 2 squared is 4, therefore z equals 1. B, find t when z is 16, therefore we got 16 equals 4 over t squared, therefore t squared equals 4 over 16, so t squared equals 1 over 4, therefore t equals the square root of 1 over 4, plus or minus, therefore t is plus or minus 1/2.